England, about 164 million years ago. In the Jurassic period, reefs flourished, reaching their peak in the late Jurassic, a crucial time for reef evolution. Unlike today's nutrient-poor reefs, Jurassic reefs boasted diverse habitats from shallow waters to depths of hundreds of meters. They were closely tied to specific environments and demonstrated a remarkable adaptability to changes in their surroundings. Liopleurodon, a carnivorous pliosaur. The paleontologist initially suggested that pliosaur skulls represented 1/7 of their total length. However, further analysis of Kronosaurus and Liopleurodon specimens indicated that skulls were actually about 1/5 of the total body length. One Liopleurodon skull suggests a total body length of 21.0 feet, while smaller individuals, measuring 16 to 19 feet, likely weighed between 2,200 and 3,700 pounds. In 2024, another paleontologist estimated that the largest known Liopleurodon could have reached around 26 feet and weigh about 17,000 pounds. A partially preserved specimen, likely from a young Liopleurodon, was found to contain numerous cephalopod hooklets, fish bones, and a single reptilian tooth in its stomach. While paleontologists cannot definitively ascertain its dietary habits, three hypotheses have been proposed. One theory suggests that Liopleurodon may have preyed on readily available food sources, such as squids. However, given the presence of plesiosaurs and ichthyosaurs, which were also plentiful, and considering that plesiosaurs likely swam much slower than squids, this scenario seems improbable unless Liopleurodon operated as an ambush predator. Another theory posits that Liopleurodon was an opportunistic feeder, with the cephalopod hooklets indicating the acid-resistant remnants of a diverse diet, skeletal remains of various vertebrates that were dissolved in the acidic environment of its gut. However, the absence of otoliths, which are typically found in the guts of cetaceans, suggests that fish may not have played a significant role in its diet. The final hypothesis is that Liopleurodon preyed on large cephalopod feeders, with the hooklets representing the remnants of its prey's stomach contents, although this claim lacks solid evidence. Additionally, this specimen contained at least 7 gastroliths, which likely were not used for grinding, given the well-preserved state of the hooklets. It is possible that Liopleurodon inadvertently ingested these stones or that they are anticorrosive residue from carbonate sandstone. Liopleurodon fossils have been found in Britain, France, and Germany. Liopleurodon's robust, paddle-like limbs indicate it was an adept swimmer. This four-flipper method of movement is typical among all plesiosaurs. Research using a swimming robot has shown that while this type of propulsion may not be the most efficient, it offers excellent acceleration, which is a valuable advantage for an ambush predator. Famously, in the third episode of Walking with Dinosaurs, titled Cruel Sea, the Liopleurodon is portrayed as a colossal creature, with the series claiming it could grow up to 82 feet long. This impressive size was derived from incomplete fossil evidence, and the estimate was considered a reasonable extrapolation by some experts involved in the production, who advocated for its scientific validity. Liopleurodon translates to smooth-sided tooth, a name that highlights the sleek surfaces of its teeth, which were the first fossil evidence used to define this genus. The designation was selected because the earliest fossils found of Liopleurodon mainly included teeth, noted for their smooth edges. This name originates from the ancient Greek terms laos, smooth, pleura, referring to side or rib, and odon, tooth. Muraenosaurus, a carnivorous plesiosaurid. Muraenosaurus was a medium-sized plesiosaur, with the largest known specimen reaching lengths of up to 17 feet. This creature possessed a total of 66 vertebrae in its spinal column, 44 of which were cervical. As one moves from the skull base towards the tail, the cervical vertebrae become longer, and the neural spines widen. This adaptation likely suggests a greater area for muscle attachment near the neck's base. Additionally, there is a gradual flattening and reduction in the area that connects with adjacent vertebrae, where the platform features have completely disappeared. Following the 44 cervical vertebrae, Muraenosaurus had 3 pectoral vertebrae and 19 mid-spine vertebrae. The pectoral vertebrae share similarities with the terminal cervical vertebrae but have a broader centrum face and a slight backward tilt in the neural spines. In the dorsal vertebrae, the ribs have been elevated onto the neural arch, while the neural spines have elongated from front to back and become vertically compressed. Muraenosaurus likely played a role in the ecosystem that is more akin to that of elasmosaurs rather than other plesiosaurs, primarily due to the similar body shapes they share. Plesiosaurs exhibit a wide range of physical forms, making it challenging to evaluate their ecological roles as a whole. Fossils of long-necked plesiosaurs have been found containing various lithified materials in their stomachs, providing clues about the diet of Muraenosaurus. It appears that their preferred prey included teleost fish and cephalopods. To effectively target such diverse prey, plesiosaurs would have required a variety of feeding strategies. Initially, it was believed that long-necked plesiosaurs were exclusively fish eaters, as indicated by their conical teeth, characteristic they share with modern fish-eating species. It was suggested that these plesiosaurs swam with their necks extended straight to ambush fish. Muraenosaurus fossils have been found in Britain. Gastroliths found in ancient marine reptiles' stomachs have led to 2 main theories about their function. One suggests they crushed hard-shelled prey, while the other claims they helped regulate buoyancy. However, modeling of plesiosaur structures indicates that using gastroliths for buoyancy is unlikely, as a Muraenosaurus would need to ingest over 10% of its body weight in stones, far more than what has been found. Instead, these models propose that gastroliths may have stabilized animals like Muraenosaurus by preventing rolling, minimizing pivoting at depth, and reducing neck oscillations against underwater currents. The name Muraenosaurus originates from the Latin term murena, which means eel. This genus was given its name due to its distinctive features, including an elongated neck and a small head that bear a resemblance to an eel. Additionally, the name incorporates sauros, a Greek word that translates to lizard. The Liopleurodon has detected the Muraenosaurus group near a coral reef, where small hydrothermal vents have formed. These vents occur when seawater seeps through cracks in the ocean crust near spreading centers or subduction zones. The cold seawater is heated by magma and then rises back to the surface, creating the vents. The Liopleurodon encircles the Muraenosaurus group, effectively trapping them. As they gradually close in, the pressure mounts on the Muraenosaurus to make a hasty escape. However, this attempt is likely to be futile, as the Liopleurodons are adept at swiftly pursuing their prey. Following an attempt by a Muraenosaurus to flee, it was quickly dispatched by a ravenous Liopleurodon.